We want to keep talking about limits, and in this video we're going to talk about infinite limits. So let's go ahead and consider this function f of x, which is x plus 4 over x minus 2. And this is a continuous function on its domain. But let's just go ahead and realize that 2 is not in the domain. So what happens to f near x equals 2? So let's look at the graph. Okay, here's our graph. Right at 2. Let's see, I probably put too much on there for right now. Right at 2, we can see we have a vertical asymptote. Okay, we have a vertical asymptote right here. And we can see that this graph is doing different things, whether we're on the right of 2 or the left of 2. So let's go ahead and consider the limit of f of x as x goes to 2 from the right. Remember that plus sign on the exponent means we're coming from the right side, from the positive side of 2. Okay, so let's go ahead and make a table of values so we can find the limit of f as x goes to 2 from the right. And we've got our x values 3, 2.5, 2.1, 2.01, 2.001, 2.0001, and we're going to evaluate them. So when x is 3, 3 plus 4 over 3 minus 2 is 7. Okay, and then we evaluate at 2.5 and we get 13. At 2.1 we get 61. At 2.01 we get 601, and we can fill in the rest. And what we see is that as x gets closer and closer to 2 from the right, we get larger and larger numbers. In fact, when x is 2.0001, we get 60,001. So what's happening is that those y values are getting larger and larger, and they're not going to approach any one particular y value. So we say that this limit as x goes to 2 from the right of f of x does not exist. So we'll abbreviate it DNE. We say it does not exist because it does not approach any particular value, but it does do something special. It gets larger and larger, and what it does is that limit goes off to infinity. So you will see this written as the limit of f of x as x goes to 2 from the right equals infinity. Now technically this does not exist. It does not exist, but you will see it written as it equals infinity because it still does something special. But infinity is not a number, so it still does not exist. Oh, I wanted to go back for a second. Notice that when we have this limit that goes off to infinity, this corresponds to a vertical asymptote. This corresponds to a vertical asymptote. So whenever you have a limit that goes to a particular number, either from the right or the left or both, that goes to infinity, that is a vertical asymptote. It's a place for a vertical asymptote. Okay, so now we're going to ask a different question. If we go back to our graph here, another interesting property is if we go off to the right or to the left, then the graph is also doing something pretty special. Notice that we have a horizontal asymptote. So how does that come out with limits? So let's see, how does that come out with our limits? So the question we want to ask is what happens as x gets very large or as x gets very large and negative? This means very large as it goes off to the right, or very large and negative means what happens as we go off to the left. So again, we're going to make a table of values, and we're going to put in x values. At this time we're going to put in x values that get very, very large. So we're going to put in, maybe you'll start at 10 and then try 100. 102 might be a little bit more convenient. 1,000, 100,000. We could put in 1 billion. But let's see what happens. When x is 10, we get 14 over 8, which is 1.75. Okay. When x is 102, so that's, relative to what we're seeing is pretty far to the right, we get 1.06. When x is 1,000, we get 1,004 over 998, which is about 1.00601. Okay. When x is 100,000, we get 100,004 over 99,998. So let me compute that. And I get about 1.000060. Okay, but what we're seeing is, what do you notice that value, that y value, that output value is getting closer and closer to? You should notice that it's getting closer and closer to 1. So we say that the limit as x goes to infinity of f of x equals 1. And that is corresponding to a horizontal asymptote. Okay. Notice on that graph, the horizontal asymptote does occur at x equals 1. For the limit as x goes to negative infinity, we could make a similar chart and make our x values get closer and closer to negative infinity. What does that mean? Get very large and negative. That limit's also going to be 1. And it also corresponds to a horizontal asymptote. So if you go back and look at our graph, we had this horizontal asymptote right here at x equals 1. Isn't the most accurate. Let's try again. There we go. That's the line y equals 1. Okay, that's no accident. Okay. If y equals b is a horizontal asymptote of a function, this occurs if and only if our limit as x goes to infinity of f of x equals b, or the limit as x goes to negative infinity of f of x equals b. Horizontal asymptotes have to do with what happens at the right end or the left end of the graph, what happens as x gets very, very large or very, very large and negative. Okay, and it has to do with that limit. Or limits at infinity, that's exactly how we figure out what our asymptotes are, what our horizontal asymptotes or otherwise.